Hi guys, today's lecture is on oligopoly, which is the market structure where we have just a handful of firms, and that's something that sets it apart from a lot of the other market structures that we've been studying. Here in oligopoly, there's a lot of emphasis that's usually placed on something called game theory. You might have heard of this before. Game theory most basically is when you're trying to analyze the decisions of a group of actors in a strategic setting. So what does that mean exactly? This takes place when the payment or the payoff that a person gets depends upon what the other person is going to do. Oftentimes you'll see this in oligopoly where there's a small number of firms because these firms are so connected, right? Imagine just a couple of, say, cell phone carriers. The actions of, for example, Verizon are going to have a really big impact on the actions of Sprint. So they need to be able to predict what the other one is going to do when they decide to raise their price or lower their price or do something different in their business model. So that's where we're at today. Okay. Two key learning objectives. One, I'm going to show you guys how to identify something called a dominant strategy. And then secondly, we're going to want to identify something called a Nash Equilibrium. Both of those are really testable ideas where you see this all the time. All right. So to start with here, I've got this little table represented here on the board. You'll see many of these in your book. And we want to at first, before getting into it too much, understand how to interpret these different outcomes, right? So when you see a setup like this, you're going to have two different players. In this case, I've got two firms, Delta Airlines up top and American Airlines over here on the side, right? And so in our game here that we're going to be analyzing for this video, each of these airlines are going to make the choice, either charge a high price or a low price, okay? The profit that each firm is going to get is going to depend upon which choice they made, as well as the choice that their competitor made. So straight away, if you want to understand what these little boxes mean, right, they correspond with the profits that each firm is going to get, assuming that they decided according to the setup of the table, right? So this top left quadrant that you see right here, that means Delta elected to charge a high price, and American also elected to charge a high price. If they both charge a high price, this is going to show each company's profit, and so on. Down here on the bottom left, this would mean American went with a low price, and Delta went with a high price. All the different combinations of high and low prices across the two firms are represented here. Okay, so that's how you work with the table. First thing that we want to be able to do then is to identify if anybody here has something called a dominant strategy. A dominant strategy. Okay. What's going to make something a dominant strategy is if it's the best thing to do, regardless of what the other player is doing. Right? If it's always better to go high price or if it's always better to go low price, irrespective of the competition, then you're going to see a dominant strategy. If sometimes it's better to go high, sometimes it's better to go low, then you would not have a dominant strategy. So let's go through and see if we can find one here. If either of these companies have a dominant strategy where they're always better off going either high or low. Let's start here by analyzing Delta Airlines, see what they want to do. So Delta's either going to go high or low. Let's first assume that American has charged a high price. We're only looking at the top row here because that corresponds with American going with this high price. So if American then has gone high, we're up on the top. Delta can either go with the high price, in which case they're going to get a profit of 120, or if they go with the low price, then they're going to get a profit of 200. That's higher, right? That should make some sense. They've charged a low price, their competition has charged a high price, they're going to be able to get lots of profit in that case. So in the event then that American has gone with the high price, Delta's best choice is to go low. All right. How about if American Airlines then decides to go low price? Let's repeat the analysis again for Delta. Right? So we're going to sort of cross out this top row and only look at the bottom down here. Right? So now Delta can go high, in which case they'll get a profit of 10, or they can get a profit of 50 if they also charge a low price. The low price option is the better. So check it out. If American has gone high, Delta's better off going with a low price. If American has gone low, Delta is better off charging a low price. And so because low price always gives them more profit regardless of the actions of the other firm, for Delta you can say that a low price is in fact a dominant strategy. All right. Let's do the same thing here for American. All right, so now what we're going to do is assume that Delta has charged the high price and see what's going to be best for American Airlines. If they go high, they get 120. If they go low, they get 200. Low is better. Okay. What about if Delta has charged the low price? So then we're going to cross off, ignore this column and only look over here. If American goes high, they get 10. If American goes low, they get 50. So maybe you could see this straight away because the numbers are just sort of mirror images of one another. But American Airlines here also has a dominant strategy, and that is to charge a low price. It's dominant because it always gives them more profit. Okay. So that then is the dominant strategy idea. Other thing that we want to be able to find here from this table is to see if we have something called a Nash equilibrium. Okay, this is a little trickier. A Nash equilibrium takes place when all the firms, all the players are doing the best thing that they can given the choice of the other firm, right? So rather than analyzing a choice and saying it's dominant or not dominant, with a Nash equilibrium, what we're doing is analyzing an outcome, right? The top right, the bottom right, and so on. Each of these quadrants could potentially be a Nash equilibrium. A good way to think of this is to ask the question, if you're at a particular outcome, does anybody have reason to change their mind? Could they be better off if they had the opportunity to sort of get a redo and choose the other strategy? If nobody has incentive to move away from that particular quadrant, then you've got a Nash equilibrium. Straight away here, I'll circle it, this bottom right one here, of low prices for all is in fact going to be our one and only Nash equilibrium in this case. It's possible that you could have more than one Nash equilibrium. It's possible that you could have none. For us on these numbers here, we have just the one Nash equilibrium, and that is low price for each. Okay, so what makes it such? Let's go through each of these possible outcomes, each of the four, and see if anybody would have reason to change their mind if they had the chance. Let's start up here with high price for both. Let's first ask the question of Delta. If you're right here, everybody's charging a high price. Could Delta be better off by switching it and going over to low price? Well, in fact, yes, they would be better off, right? If they're both charging high price, they're going to be getting 120. But if Delta had the opportunity to flip it, then they could get $200 of profit. Their profit could go up if they were able to change their mind. Therefore, this is not a Nash equilibrium. Let's see here. What about this one over here? Low price for Delta, high price for American. Could anybody be better off by changing their mind? Let's see here. If, let's say, Delta decides to change their mind and go from low price to high price, does their profit go up? No, it doesn't. It goes from 200 to 120. So Delta doesn't have reason to switch. What about American? Would they have reason to switch? Here they're charging a high price. If they could switch to a low price, their profit will go up. So they do, in fact, have a reason to switch. So again, both of these top two cells are not Nash equilibrium because at least one player could be better off by switching. Let's contrast that with what we see down here in the bottom right, where we do have that Nash equilibrium. Both firms here are charging low prices, and they're going to get profits of 50 each. What if American switched to a high price? Well, their profit would go down. American doesn't want to switch because that would cause their profit to go from 50 up to 10. What about Delta? They're getting a profit of 50 here. If they switch, then the new outcome will be represented by this one over here. Their profit will go down to 10. So if you're at this cell over here where both firms are charging that low price, neither one of them is going to want to move away because moving away will cause their profits to fall. And that's what makes this bottom right quadrant of both firms charging a low price our one and only Nash equilibrium for this particular problem. Voila.